So problem 1 says find g of h of a. So what we're going to do is we're going to find g of h of a. H of a is a function of 2a cubed plus 3. So what this means is wherever we see a in the g function, we're going to replace it with 2a cubed plus 3 plus 5. So then we're distributing here, negative 8a cubed minus 12 plus 5, and g of h of a gives us negative 8a cubed minus 7. Same type problem here, g of h of x, g of h of x, which is 3x plus 1. So wherever we see x in the g function, we're going to replace it with 3x plus 1 minus 3. Distributing 9x plus 3 minus 3. These two guys cancel out. So g of h of x equals 9x. So in this problem, we're taking this, it says find g plus h of t, which is like saying g of t plus h of t. So g of t is just negative t minus 2 plus h of t, which is t cubed plus 4. So we just combine together like terms. We have a t cubed term, so that's going to go first in standard form. There's no t squared terms. There's only a negative t. And we have negative 2 plus 4 is positive 2. So the function g plus h of t is t cubed minus t plus 2. Same idea here, g of n plus h of n. So g of n is n cubed plus 5n plus h of n, which is 4n plus 5. N cubed. 5n plus 4n is positive 9n plus 5. So g of n plus h of n gives us n cubed plus 9n plus 5. So in this problem, what we're finding is 2 times the function h plus 5 times the function g, all at negative 1. The easy way to do this is to put 2 times 2x minus 1, but we're given our value of x, so it's 2 times negative 1 minus 3. All right, so that's the first part of this, plus 5 times g function, which is 2. Again, negative 1 is our value that we're given. Okay, so we just crunch some numbers here. 2 times negative 2, or excuse me, 2 times negative 1 is a negative 2 minus 3. So we're getting 2 times negative 5. Over here, 2 times negative 1 is a negative 2 plus 4 is 2. So here we're getting plus 5 times 2. So negative 10 plus positive 10. And the function 2h plus 5g of negative 1 equals 0. And yes, 0 is a valid answer. It's a number. This guy's a little bit different because this one says find, number 6, a little bit different, g of h of negative 10. It's easier if you start writing it g of h of negative 10. Just easier for me because you can find this, h of negative 10. All right, so h of negative 10 is equal to negative 10 squared plus 2 times negative 10. Negative 10 squared is 100. 2 times negative 10 is negative 20. 100 minus 20. H of negative 10 is 80. So if we know this is true, we can take 80 and stick it in here and find g of 80. Okay, so g of 80 would be 2 times 80 plus 3. 2 times 180 is 160. Plus 3 in our combined function g of h of negative 10 is 163. So this problem is asking us to find g of 3 times h of 3. So again, the first thing we want to do is figure out what g of 3 and what h of 3 are, and then multiply them. So g of 3 is, we're taking the g function up here, so it's going to be 3 cubed minus 3. That would be g of 3 times h of 3, which is 3, place an a with 3, plus 4. So we got to work inside here. 3 cubed is 27, minus 3 is 24. 3 plus 4 is 7. So our function, g of 3 times h of 3, is going to be 24 times 7, which is equal to 168. This guy is similar to the one we did before. 4 times f, but we know the value of x is 8. So in the f function, this guy, we're going to write 4, that 4, times the f function 4 times 8 plus 2 plus g of 8, which is 8 squared minus 3 times 8. Again, crunching stuff inside here. 4 times 8 is 32 plus 2, so we're getting 4 times 34 plus, in here, we're getting 64. 8 squared is 64 minus 24. 4 times 34 is 136 plus 64 minus 20 is 40. So our function 4f plus g of 8 is going to be equal to 176. So for questions 9, 10, and 11, it's asking if, or it says state if the given functions are inverses. Now remember, if two functions, given functions, are inverses, that would mean f of g of x has to equal x, and g of f of x has to equal x. If it does, the two functions are inverses. If either one or both do not equal x, then they're not inverses. So let's find the first one here. F of g of x, right? So f of g of x, f says 3 minus 2 times this function, cube root of x minus 3 to the 5th power. So when we're doing this expansion here, this cube root x minus 3 to the 5th power, we're not going to get it down to x. This is going to be some big funky polynomial. So no way is this going to equal x. Equal x. So doing binomial expansion, or if you just went radical x minus 3 times 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 radical x minus 3, which would be radical x minus 3 to the 5th power, we're not going to get it to get anything where it's just x. And then we have this over here, so it's not going to work. So these guys are not inverses. Sometimes you just have to start it and you can figure out it's not going to happen. On this one, again, we need to get f of g of x. Okay, so f of g of x, this is going to be 2 over, I'm putting the plus one so I don't forget it. So wherever we see x, we're going to replace it with this whole thing. So this is negative, and then we're looking at the function on here, negative 2 over x minus 1 minus 3, right? And then minus 3, because that's still in the denominator. So the first thing I want to do, so this part, this is all here, right? That's the g of x, what I replace it with, and this is 2 over negative x minus 3, right? Pop it in there, and we're good. Okay. So we just got to do some crunching here. 2 over, and again, plus 1. We're distributing this, so we're going to get 2 over x minus 1 plus 3 minus 3, and all that plus 1. These guys cancel. Agreed? Me too. So we're getting, this is 2, which is like 2 over 1. So we can just take our fraction, 2 over 1 times x minus 1 over 2 plus 1. What happens to these guys? They cancel out. So now we have x minus 1 plus 1 equals x. So f of g of x equals x, part 1, down. How about g of f of x? Same type idea. We're going to pop this in here. So this time we're using the g function. G function says negative 2 over x minus 1 minus 3. So where the x is, we're going to stick in this 2 over negative x minus 3 plus 1 minus 1. Agreed? Agreed. So combining this stuff in the denominator, right? These guys are going to cancel out. Okay. So now we're going to do this. Remember, this is like negative 2 over 1. So negative 2 over 1 times negative x minus 3 over 2 minus 3. Negative 2 over positive 2 makes this negative 1. Distributing this, we're getting x plus 3 minus 3. These guys cancel out, and we're left with x. So g of f of x and f of g of x both equal x. So these two are inverses. Now you have to show the work. You can't just guess. This one was a little bit messy. I get that, but just go through it, and we're going to do good. Last one of these guys. Okay, so let's find g of f of x. So g of f of x is going to be 4 plus 1 over x minus 1, but our x is going to be all of this, 4 over x minus 3 plus 2 minus 1. Okay, so what are we going to do? We can drop the parentheses in the bottom, so we're going to get 4 over x minus 3, 2 minus 1 is positive 1, plus 1. These guys are going to have to get a common denominator, so we can combine them. So 4 plus x minus 3 over x minus 3 is going to give us x plus 1 over x minus 3. Okay, that's just the denominator, and we still have 4, and we got plus 1. Okay, so now what? Flip it and multiply. Flip this fraction. So 4 over 1 times x minus 3 over x plus 1 plus 1. Distributing here, we get 4x minus 12 over x plus 1 plus 1. Okay, so we need to get a common denominator so we can add these guys together. So multiply top by 4x plus 1. So now we have 4x plus x gives us 5x. Negative 12 plus 1 gives us a negative 11. All this over x plus 1. Does this look like it's equal to x? It does not. It will not be equal to x. So these two functions are not inverses. Again, if it doesn't work for one, they're not inverses. If it doesn't work for both, they're still not inverses. if g of f of x and f of g of x both equal to x, they are inverses. We're done. Okay, so 12, 13, 14, and 15, we're finding the inverse of the function. So what we're looking for is f inverse of n. Now remember, there's a very systematic way to do these things. First thing is replace f of x, f of n in this case, with y. So that's equal to negative n plus 3 to the fifth. That's the first step. Second step, switch the x and y values, or in this case the n and y values. So we're going to get n equals negative y plus 3 to the fifth. Okay, we want to get this term all by itself, so multiply both sides by negative 1. So negative n is equal to y plus 3 to the fifth power. Well, we need to get the y by itself, so we're going to raise both sides of the equation to the 1/5 power. 1/5 power is like taking the fifth root of n, and this is just going to give us y plus 3. Okay, those guys cancel out. Okay, subtract 3 from both sides, so the fifth root of negative n minus 3 equals f inverse of n. F inverse. F to the minus 1 of n. Okay, relatively doable. Same type thing here. We want to find g inverse of x. So first thing, change g of x to y. This is equal to negative 2 over x plus 1 plus 1. Swap the x's and y's. X is equal to negative 2 over y plus 1 plus 1. I'm going to subtract 1 from both sides. X minus 1 equals negative 2 over y plus 1. Now these guys, we want y by itself. It's in the denominator. We can't have it there. So we're going to multiply both sides by y plus 1 and divide both sides by x minus 1. Basically, we're cross multiplying. So this and this are going to change places. So we get y plus 1 is equal to negative 2 over x minus 1. We want y by itself, so subtract y. Y equals negative x, or excuse me, negative 2 over x minus 1 minus 1. So g inverse of x equals this. Negative 2 over x minus 1 minus 1. For these last two, we need to find the inverse. So g inverse of x, we would go y equals 3x minus 6. Switch x and y. X is equal to 3y minus 6. Add 6 to both sides. And divide everything by 3. So 1/3 x plus 2 equals y, or g inverse of x equals 1/3 x plus 2. Marvelous. For this guy, same idea. We're getting f inverse of n. So replace f of n with y is equal to negative 3. I'm just going to put the negative up there so don't forget about it. Negative 1 plus 3. Switch n and y. N goes here. Negative 3 over y minus 1 plus 3. Subtract 3 from both sides. And minus 3 equals negative 3 over y minus 1. Cross multiply both sides by y minus 1 and divide both sides by n minus 3. So we're going to get y minus 1 is equal to negative 3 over n minus 3. Add 1 to both sides is negative 3 over n minus 3 plus 1. So f inverse of n equals negative 3 over n minus 3 plus 1. There we go. Study this stuff up. Be ready. Okay. We'll review on Wednesday, and the test is on Friday. 2 sections of Chapter 6 and all of Chapter 5. Good luck.